already we have learned some problems of the k-means and k-means plus plus. In previous lecture, we have seen there have some problem of the k-means and k-means plus plus as well. There have also some problems. Now let's discuss what kind of the problems also we have seen for the k-means. So the k-means that already we have seen, k-means or k-means plus plus, both the algorithms. So what do we have to do in the k-means or k-means plus plus? We have to we have to predict the centroids. We have to predict the centroids for our data sets, and based on the centroids, we have to make the clusters for each centroids. That's the job we have to do in the k-means, but there have some limitations. There have some problems. There have some problems. What is the problem? The main problem is this centroid that we have to predict it. It is may not be interpretable. Some okay. The centroids may not be interpretable. That is the main problem. Okay. So why this is not main interpretable? Why? The questions arises. Why? Why this is not interpretable? Now let's understand this thing. Why these things are not interpretable? Because the data set we have, so let's take the data set we have like that, x1, x2, these are the data set we have. Now by simple first we have already since in k-means plus plus, first we have to take randomly, you have to select randomly any point from this data set, and we have to take it as a first centroid. Okay, and now based on that centroid, we have to use some probabilistic approach based on the distance from the other point from that point, and from the based on that probability we have to choose the next, what will be our next centroid. That's the method we have to we will use to the k-means plus plus algorithm. Just if you forgot this, just recap that video. I think it will be better for your understanding. Okay, so it will be better if we just take an examples, just discuss through an example, it will be better. So suppose let's take the example, the data we have collected. Suppose let's take from any e-commerce website. Suppose let's take from Amazon. So we have collected some product review text from Amazon. Let's take Amazon. We have collected some product review text. Product reviews. Yeah, we have collected some text. So by simple using some technique we have known already. This is our text data, text format. By simple using some technique we can convert this text to a vector. Suppose let's take this is our review text. This is our review text. Okay, this is our review text, and now simple using the backward or TF-IDF, any kind of technique we can, if you use, then you can encode this review text to a vector format. This is easily done. So I'm not going to discuss these things. We can easily do this job. Now the question is the from the data set, the centroid that we have make, that centroid. Suppose let's take from the data set, from this data set, the centroid using simple the k-mean or k-means plus plus, the centroid that we have predicted here. Suppose let's take the centroid that we have predicted, C1, C2, C3, CK. This centroid we have predicted from this data set. Now the this centroid is how do we calculate it, this centroid? Just remember the updated centroid part means in our K means algorithm they have 4 part. First part is initialization, second is assignment, third step is recompute or update the centroids. If you remember this step, this third step, then on that step we have computed the centroid by using simple means of the point of that cluster. We will compute this thing. We have computed this centroid by simple using the mean of the points. Mean of the points we have calculated this thing. So suppose let's take the the value that we have calculated from here. This is actually after using some back of word or some techniques. This text is not a text format. This text are actually a vector format. So suppose let's take the using the mean, the value we will calculate it like that. This is a first vector, w1 vector, w2, w3, like that, somewhere like that. Back of word. Suppose let's take this is the sum value. Suppose let's take 0.8. This is sum value or 2.4. This is sum value. Suppose let's take 3.6. Sum value 0. Like that. Like the value we will got from here. But since we have used the mean of all the vectors of the review vectors, so to read this vector is totally impossible. To read this vector, to what actually this vector is totally impossible. So to predict what is actually the vectors, to read means I'm talking about the read this vector is not possible. Is not possible. Okay, because we have taken the mean. If these centroids are lying on that point, then it can easily saying this text, then we easily predict this thing. But the centroid that we have computed here, that's have been taken by using simple mean of that points. So because of these reasons, it's read this vector is impossible. Okay. Now the thing that how we'll solve this problem, how to predict this centroid, how to. So now how we'll solve this problem? How we'll solve this? Okay. So we'll solve this by using, instead of using the CJs, computing using mean, if we use instead of the solution is like that. Solutions will be like that. Instead of using in the vector CJs, instead of using CJs as computed using mean, the centroid that I have used by simple using the means, instead of using CJs that is computed using mean, if you give me some points on this data set, suppose let's take, if you gave me some points xi's data set D as the first centroid, as the centroid, simple centroid, as the centroid, then since the centroid is lie on our data set, so by simple then we can easily read this thing. Then simple, since these are in our data set, then we can easily review text and we can understand what is this review talking about. Then we can simply read this text, this review, and understood what is talking about this vector, what is talking about this review. We can easily understood this thing. Okay, since these review are now live data set. Okay, so now this is now interpretable, easily interpretable. This is now easily interpretable. Okay, and now easily interpretable means what kind of sense it is interpretable. By simple saying this vector, we can find that it is a positive text. We can interpret it about this review. Is it positive or negative? Means we can interpret it, its polarity. What is its polarity? What kind of review is it? What kind of review it is? Either positive or negative. What kind of review? We can easily predict by simple, because this vector is now on our data set. But in previous step, we have using simple the mean of the point. So since this mean now may not be lie on our data set, so it may not be lie in our data set, so we cannot predict about its interpretability, what kind of text it is. We cannot predict, we cannot interpretable about this text. Okay, I think you got that. Now the question is how to doing these jobs, how to doing this job that have that possibles to interpret it. How will doing this job? Let's see. A big idea to use this concept, the big behind the big idea is like that. Big idea is, what if the centroid is like on the means the centroid that we have picked up randomly from our data set. Okay, that we have picked up from our data set first randomly and then use the probabilistic approach to predict the next centroid, and the third step we have used the mean. So just we have to update the third step. So now question is, how will update this thing? Let's see. So the updated by simple using the, instead of using the mean, if we use the, what if we use, what if our eighth centroid, is a data point, is a what if our eighth centroid is a data point, means what? If centroid lies on the data set, data point lies on the data set, what if these things are happening? Means I'm talking about means that means the CJs that we have taken, that is actually our data points, means that is some data points on our data. Let's take D. What if these things are happening? So the concept behind it is the concept of K-Medoids. The concept behind is, the big concept is, we will use the K-Medoids technique. K-Medoids. Is K-Medoid? What is K-Medoid? It's the simple probabilistic a popular algorithm. K-Medoid is a very popular algorithm. Just a minute, we will see these things, how we will compute this Medoid thing. It's a very popular algorithm as well. It's the we can easily interpret it about our centroids. We can easily interpret it, interpretable. It is easily interpretable. Okay. Now let's see how we will compute these Medoids. So to compute this Medoid, the technique that we have acquired here, the technique that we have acquired is called the PAM technique. PAM means partition around Medoid. PAM technique we have to use. Partitioning around Medoids. This technique we have to use. In short, this technique are called PAM. PAM technique. So the concept behind it, big concept, the big idea behind it, the PAM technique to compute the K-Medoids. Okay, now let's see this thing, how to compute. So already we have learned. So in K means there have four stages, So the same stage we will apply here, but some modifications we have to. The first stage that we have seen, the initialization stage. Initialization. Initialization stage. So what we have doing initialization stage? Simple, we have to use the K means plus plus algorithm. The same technique. The same technique also will apply here. So to compute the K-Medoids. K means plus plus, we have to apply the K means plus plus in the initial stage. And so this is the probabilistic method to pick K points from the D. These are the probabilistic method. We have already learned this thing. These are the probabilistic method to pick K points from D. This is a very popular one. Already we have seen this thing. So now the second stage that we have learned already. In second stage, the assignment stage. The assignment stage. This is the initialization assignment. Sure. For the assignment stage, the same thing also we will apply here. It's the same as the previous one. Don't change anything. This is the closest, means same as K means the same thing, same as this is the same as our K means technique. Okay, so to find the closest Medoid, so what do you have to do? So to find the closest Medoid, so here the xj, suppose let's take the xi, any point xi, any point xi, it will be lie on the cluster sj if the Medoid j if the Medoid j is the closest, if the Medoid j is the closest Medoid, closest, if it is the closest Medoid to the point xi. If this happen, then we can take the xi is like on the our cluster, the group sj. That's things already we have seen. Same, that these same things as our k-means that we have already seen. Now the main changes are here. Now the main changes here: update or recompute the centroids. Update stage, or you can compute it the recompute stage. Recompute. In that stage, we have to make the changes. So just remember, in k means, what do you do? In k means to compute the mean, to compute the centroid, we will use this formula. Is the number of points on that cluster and the summed value that belongs to sj. A simple summed up value. Summed up. It's called. That's formula we will use to compute the centroid, update the centroid for each cluster. Okay, that's formula we will now don't use this formula. We have to modify. We have to modify this formula. Okay, now let's see how we'll modify this. How we'll doing this job. Let's see step by step. So the K-Medoids, instead of using k-means, here we will use the concept of K-Medoids. K-Medoids. So let's try to understand this K-Medoid step by step. Okay, let's try to. It will be better if we take through if we discuss these things through an exam. Suppose let's take the data set. On our data set, we have 10 points. Suppose let's take on our data set, we have 10 points. Suppose let's take the points are like 1, 2, 3, 6, 4, extend. We have this point. Suppose let's take first thing that we have to do. We have to first pick up a random value and treat it as a centroid. First thing that we have to do, we have already seen this thing. First we have to pick up any point. Suppose let's take here k is equals to let for simplicity let k is equals to 2. So we have to pick 2 points randomly from here. Suppose let's take we are picking here x1 and x6 and to take this thing as a first Medoid, and this is the second Medoid. Let's take these things. Now after picking up, these are the Medoid point now. Now these are the what? These are the non-Medoid points. These are the non-Medoid points. These are the non-Medoid points. Okay. Now after picking up, what do we have to do? We have to swap these Medoids to the non-Medoid point. Means we have to swap each Medoid point to this one. How will? Means, so what is Medoid here? Here m1 is Medoid, means x1 is the Medoid, the x2, x3, x4, any non-Medoid we have to solve. Suppose let's take, we have to solve this point to that point. So we will solve this point to here, and now we have Medoid will be now x2 and the x1 now it will be non-Medoid. Now x1 now will be non-Medoid. This will be now Medoid and x1 will be non-Medoid. The same things also here applicable. So let's take, we will interchange these things. Okay, the thing that we have to do. Okay, so let's try to understand these things step by step. Let's try to read these things step by step. So in first step, we have to swap this thing. We have to swap each Medoid with a non-Medoid point. With a non-Medoid point. First thing that we have to do it. Okay. First we have to swap the edge Medoid to a non-Medoid point. Now the second stage, that we have. Second stage, if we have to compute the loss functions. We have to compute the loss. Now the question is, how will compute this loss? Just if you remember the mathematical optimal functions that we have computed, just remember this thing. How will computed this mathematical optimal function? If you remember this thing, we'll computed this by simple using the sum up formula. Okay. Just remove this now. Just try to understand the going mathematical optimal function that we have built by taking the simple summed up value, where this is the number of clusters that we have considered. Now this summation is for number of points in our edge cluster, number of edge cluster, and these are the square distances from our Medoids. Okay, these things we have doing in the math to formulate the mathematical objective functions. This is actual the Medoids J. These are actually the Medoids J. We have seen these things, and this is simple the loss functions of the K-means algorithm. This is the simple the loss functions of the K-means algorithm. This is actually the loss in K-means. We have seen these things. Now try to understand using this formula, these loss functions, how we will compute the second step. In the second step that we have to compute, after swapping this, we have to compute if the loss decreases. If this means from the first centroid, we have to calculate it how much loss we have after swapping this centroid point. After swapping this centroid means Medoid points. I'm talking about this Medoid. So first Medoid we have x1, x6. By simple using the x1 and x6, we will calculate it what is its loss functions, what is its loss value. Now after swapping this, now again we will compute what is the loss value for this one. So if the loss is decreases, if the swap, otherwise undo the swap, means we have to do nothing. Again we have to swap the next point. That's thing we have to do. If the loss decreases, then we have to make this swap, keep the swap. Keep the swap means now we have to treat this point as our centroid, else if it is not, else undo the swap. Else we have to return the swap. Again we have to remake again this one our main centroid. We have okay. Now again we have to next pick this point as our centroid. If this was happen, then it will be our centroid. Otherwise it is our main. It is our main sum. Main centroid means centroid. Undo the swap. Okay, that thing that we have to make. This is the second step. Okay, now try to understand through the algorithmic point of view. Now let's try to understand through an algorithm. Suppose the data sets that we have, let's try to understand through that these two steps actually we have to make. Okay, let's try to understand through the same examples in algorithm point of view. data set where we have x1, x2, x3, x4, x5, x6, 7, x8. These 10 data we have. So first, let in first step, let the loss value. Let's take the x1 is equals to m. Let this one is equals to m1. And x6 is equals to the second. This one is equals to first Medoid and this is the second Medoid. Let's take x6 is the second Medoid. Let's take, and the loss value for this one is, by using this formula, the loss value is, suppose let's take for this two Medoid, let's take its loss value is L1. First step we have to do. Now in second step, we will make some swaps. Suppose let's take, we will now make some swap. We have make some swap as x2 as our next. We'll make some swap from here. So we'll make swap. Now our m1 is equals to x2 and m2. Sorry, m1. It is the m1. And m2 is equals to x. Suppose let's take x m2, and suppose let's take its remain same. Let's take we will remain same this x6. Now we'll sample x1 as a here, x1 as a non-Medoid point. And x6 remains same. So let's take, if you're interested then we can do, but let's take, we will remain the same x thing. Okay, now we'll compute the loss. Suppose let's now compute the loss value. Okay, suppose let's take the loss value that we computed here. Let's take the computed loss value is L2. I sample using m1 is equals to here x2 and our m2 is equals to x6. Using this Medoid, we will compute this loss value is equals to L2. Okay, by simple using this Medoid, we will compute this L2. Now we have to check if this L1, now we have to check if this L2 is less than L1. If this is okay, then we can treat, then we can make that m1 is equals to x2, m2 is equals to x6. We will make this. If this happens, else otherwise what do we have to make? We will make m1 is equals to same as previous x1, m2 is equals to 6. Okay, that's the job we have to do. So this stage means what? If this stage is happen, means if L2 less than L1, this is means what? This means our swap is successful, then we can call the swap value is successful. This means that this is swap are successful. So we have just see these things. We have 10 points. So how much swap is possible here, lot of, because if the data sets are our large number of data sets we have those, so there may possible say a large amount of swaps. So the number of swaps are possible here a lot. So lots of swaps, that's the main drawback actually for this. We will remove this drawback. lots of swaps that are possible. These are the main drawbacks. These are the main drawbacks. These are the main drawback of this algorithm. There are lots of. So if your data set is large, then this is possible. Lots of. So this is the main simple. The advantage. This is the drawback of the time complex, but they have some advantage also. So there have some advantage also. Now let us discuss what is the advantage of this. You have some advantage also. Let's discuss this. What is the advantage? The advantage is here. So if we have the kernel matrix, if you remember the logistic regression chapter, then we will discuss there the kernel matrix. Kernel matrix is what? So if what actually doing here, just see these things. Actually, we will find the distances. We will find the distances here to find the loss value. We will find actually the distances. Based on this loss value, we will make our centroid by simple swapping these things. So at the end of the main calculations is we have to make these distances. We have to find these distances. Okay. So the advantage is here. Advantage is if instead of using these distances, x minus mj square, if someone gives some similarity value, or if someone gives some distance value, of similarity value of I'm talking about xi, just call it xi mj. Actually mj is a data point. Just see this thing, mg, the Medoid point that we have taken, is actually data point, really a data point. Okay. So if someone gives the similarity value of the 2 points or distance value of the 2 points, okay, then we can easily find. So these things are actually called kernel value. If this kind of representations someone gives us some representation x's, these are the kernel matrix we have seen already. These things are called the kernel matrix. Okay, if someone this value, then we can easily find this value. Okay, this is the main advantage, one of the advantage, and also there are some advantage. This is the one of advantage. By simple using the if someone gives this some matrices, some kernel matrices, then we can also easily find its center. But the things are not possible if we use the simple k-means algorithm. But in K-Medoids algorithm, it is possible. Okay, this is the one advantage. This is the first advantage. Second advantage is it's interpretable. Because the centroid that we have chosen here is our data point. So these centroid are actually our, see this thing, the centroid. In K means the centroid is may not lie on a data point. We may not be interpreted sometimes, but in K-Medoids technique, it's lie on our data point. So it is possible to interpret it. The second advantage is K-Medoids is interpretable. First thing, it is interpretable. Okay, the second thing is it is kernelizable. Possible. Kernelizable is possible. Kernelizations is possible here. Kernelization means simple, we can use the some similarity matrix or distance matrix. We can use some kind of, so it is possible. So this is the main to advantage. Also there are some advantage and drawback also. So these are the main advantage and this is the main drawback of this algorithm, because here possible lot of swaps. If our data sets is large, so sometimes it's not possible to make a quick response model. It is not possible. Okay, this is the main drawbacks of this. There have some hacks to remove these drawbacks. We will see these things. We will learn these things in the next video. Okay, I think from these lectures we got the idea how these K-Medoids actually works. Just to recap these things. So the same things also we have to take, instead of we have to just modify the third step. If you just recap this thing, if you just recap this lecture, so first, to build the K-Medoids, that will be the data points of our data set. We have to take the partition around the Medoids. Partition around Medoids technique we have to occupy. So this is the same technique. And first stage is initialization. So initialization stage is the simple probabilistic method that we will already seen in K mean plus plus technique. That things already we have seen. The same things also we have to maintain. The second stage, the assignment stage. In that assignment stage, it is the same as the K means, and means the points that we have to that are the closest to the Medoid, that points we have to take as our cluster point. Same thing, but the main update is here. Okay, instead of using the mean concept here, we will to use the Medoid concept here. Medoid means there are only two steps. First step is pick any random value from our data set. Okay, and we have to calculate its loss value. Now after calculated the loss value, we will swap this value to the non-Medoid value and make the Medoid to the non-Medoid. Okay, that's things. Now we have to, after swapping this, we have to calculate the loss value. If this loss value is less than the previous loss value, then we can call our swap is successful. Otherwise, we will undo this swap. Okay, and the main drawback of these algorithms is there have possibles lot of swap. If our data set is large, so there have possibles of lot of swap. Okay, this is the main drawback, and main advantage of these algorithms is it is interpretable and kernelizations is possible here. Means everywhere give us the pair of simple relations between two pair of points. How much similar our data point is and how much distance. Anyone kind of give some kind of relations about two pair of data points, then these K-Medoids algorithms are possible. That in previous sample, if you using a K means, that may not be possible sometime. Okay, and I think you got the idea behind the K-Medoids algorithm. Okay, now in next lecture, next video, we will see how to remove this drawback of this K-Medoid. We'll see these things in the next video.